Okay, this is Dr. Mitchell, and we're going to walk through some of the basics of temperature regulation, and we'll get into this in regards to exercise as well in another video. But in this video, we want to look at just some of the basics of how, as humans, we regulate body temperature, the importance of that, and then we're going to walk through some of the main means to which that we do so. So to understand heat balance or maintaining normal body temperature, I want to go through some of the basics of heat balance when it comes to humans. So generally speaking, humans, if we want to compare us to most mammals, not the best at maintaining or keeping core temperature well. Our normal body temperature is roughly 37 degrees Celsius, or as most of you know, 98.6 degrees Fahrenheit. And generally speaking, we're pretty good at keeping it close to that. However, we don't generally, without clothing, without other means to help us, we don't generally do well in extreme environments. So what I mean by that is if we were to be in 40 degrees weather, or let's say 5-6 degrees Celsius for an extended period of time without clothing, we would develop hypothermia, ultimately likely die from that. Likewise, if we're in high ambient temperatures, even just slightly above our body temperature for extended periods of time, we would suffer from heat stroke and other issues. So, but having said that, there are obviously many ways we attempt to keep body temperature normal, and not surprisingly, it's a really important function to do. So when you think of heat production, and we're going to really focus on heat loss because generally when it comes to activity, we are focused more on that. Generally, we struggle more in warmer environments than colder environments. And so typically heat loss is a bigger issue. However, heat production is a part of this in the sense that we do produce a sizable amount of heat. And in fact, much of the energy we expend during activity, we do release as heat, a large part of it. And so we have to dissipate, get rid of that heat effectively. Now, we do that voluntarily. We do that involuntarily as well. We experience this more in cold environments when it comes to shivering, which is kind of a rudimentary way of trying to increase body temperature through muscle contraction and heat production that way. We also have other hormones, thyroid hormone, which is thyroxine, and some other epinephrine, norepinephrine, which also play a role in helping to produce heat. But when it comes to activity, and arguably when it comes to anything in regard to heat loss, there's really four key mechanisms that we utilize. And we don't utilize these equally. When it comes to at rest, some of these are more important. When it comes to exercise, we'll see one of these is the most important. But each of these plays a role in heat loss. And not surprisingly, all of us have likely used all of these, and you can easily come up with an example of each of these as a means to which we've tried to cool ourselves down or lose heat, dissipate heat when exercising in warm or even humid temperatures. So I wanted to hit these one-on-one, and we'll go through the basics, what they are, why they're so important. So conduction, convection, radiation, and evaporation. So let's start with the first one. And I'll kind of go in a different order here. I'll go with the order of how these are important probably at rest, and then we'll deal with evaporation last, which is key during exercise. So the first one is radiation. So the best definition of radiation is heat we lose or heat we gain, because it can go both ways, via infrared rays. Now, the best way to think about this practically is how often have you been out in the sun? It's a warm day, and you naturally, when you go into shade, you start to feel cooler. Now, the truth is, the ambient temperature isn't that much cooler in the shade. What you're experiencing is radiational heat, and when you're in the shade, you don't experience that as much, and so you will experience less heat. This goes obviously the other way. When we're in cooler temperatures and we're out in the sun, we feel warmer, even though the temperature largely is still what it was in the shade. And so at rest, a lot of heat loss and heat gain is gained in this manner, more than half of it. And this is why in warm temperatures, we try to stay in shade, right? We try to get under an umbrella or something that'll get us out of the quote-unquote sun. How often have we exercised out in the sun and the clouds come in? It's like, we feel a little bit better. We're experiencing or using radiation in a way to manage heat loss and to improve heat loss, right? Likewise, if we want to cool our temperature, we stay out of those environments, right? We get into the shade. We do those things to do that. So radiation is a key means of heat loss. Another is conduction, and the best way I think of conduction is touching a surface, right? And you think of conduction more in an electrical sense, right? Water is a good conductor of electricity. Well, with conduction, when we talk about heat loss, we're talking about losing or dissipating heat via contact with another surface. You've probably experienced this in both heat loss and heat gain. How often have you gone into a car and it's a warm day and you have vinyl seats and you have shorts on and you sit on the seat and it feels like it's 200 degrees, right? Well, you have contacted a surface that is incredibly warm. It's absorbed heat and you are feeling that. Likewise, how often have you been really warm and you touch something cold like metal or even ice, put that on your forehead to cool yourself down, right? That's a means of using conduction to dissipate heat. And it can be effective. Now, obviously it's limited, right? There are some activities in regards to exercise that we can't readily use conduction, at least not easily. But it is definitely a means to which we can attempt to lose heat. The last one is convection, and convection is the transfer of heat via air or water or some fluid. And if you're familiar with cooking in convective ovens, you understand that convection ovens move or use air, movement of air in regards to heating things. So that's what convection is using air to dissipate heat. And the best example is if you're overheated, you get in front of a fan, the fan blows air on you and you immediately feel cooler. Well, the truth is that air is not really that much cooler. Right? It's the same air that was in the area you've been in. But what's occurring is that air is moving warm air that's on the surface of the skin. It's displacing that, causing a heat gradient and allowing you to lose heat a little more quickly. And we feel cooler. And it does work. I mean, obviously we can feel cooler. We dissipate heat that way. Again, it's a bit limited as far as how well that works during exercise, right? Unless you have a fan right in front of you, unless it's a really windy day, it's hard to naturally cause convective heat loss. But definitely if we have a fan or something that can move air like that, it is incredibly valuable. It is also this, and to a degree, conduction, one of the reasons why we struggle with changes in body temperature in water. One of the things we'll talk about in our next video is that we are far more likely to become hypothermic in water as opposed to heat. In other words, if you are in outdoor conditions where it's 58 degrees Fahrenheit, you're likely to be fine. I mean, you may complain a little bit, but you're not going to get hypothermia and die. However, if you were to swim in 58-degree water, you would experience hypothermia within a few hours. And it's because of the density of the water, and it's going to allow heat to dissipate far more quickly. The water moves, and so we're seeing a little conductive and convective loss of heat that way. Now, all these three means are key during rest, and to a degree, they can be helpful in some activities if we can find shade, right? If there's windy conditions, if we can utilize colder surfaces. But the truth is, during exercise, the best means we have to dissipate heat is evaporation. And so evaporation occurs when water becomes vapor. And with that, it also then loses the heat of that water to the air as well. And during exercise, this is the best means to lose heat, at least in humans. That is important. Other mammals aren't great at heat loss. If you have dogs, dogs have far too much fur. They don't have the sweat glands we do, and so they have to pant and breathe heavily. We don't, but evaporation is really key. And one of the most important things in regards to evaporation is understanding humidity. So the best way I can kind of explain this is by trying to draw this. And let's just imagine we are running, and I'm going to do a terrible picture here, right? So we have someone who is running, right? And let's assume that as they are sweating, right, that sweat, and we'll just draw some sweat here. There's the sweat coming off of them. That sweat is 100% water. Okay, well, why is that important? Well, let's say the air has, I'll make up a number. Let's say we're in a dry area. Let's say the air is 30% humidity, right? Well, that's important because if we have our sweat, which is 100% water, and the air, which is 30% water, that creates a gradient. And evaporation occurs fairly easily. And so this water that we lose via sweat, it evaporates. We cool down fairly quickly, and this works incredibly well. Now, let's say, however, you're in a humid environment. Florida is a great example, where quite easily, particularly in late mornings when you're close to the dew point, it could easily be 92% humidity. Well, now we have far less of a gradient here for evaporation to occur. And so what happens is this water doesn't turn into vapor. And it doesn't cool us off. And so we continue to sweat and sweat and sweat. And you've probably experienced in warm, humid conditions, we sweat a lot. And it's because this evaporative process is not working like it could. And as you can imagine, in a situation where it would be like 100% humidity, which is not uncommon, or at least close to that, it nearly becomes impossible to lose heat via evaporation. And so as much as we're thinking about ambient temperature here, and that being a big factor, arguably humidity is as important a factor into this. And if we're exercising in really humid environments, that is as important and as problematic as warm ambient temperatures. Okay, so as we go back to our slides here, I want us to grasp that evaporation is going to be a key part of this, right? And we can, thankfully we have large stores of water. Most humans have in a ballpark of 30 to 40, 45 liters of water. Now, a lot of that is intercellular water. It's not water we're going to lose easily. But we have ample, at least to a degree, amounts of water where we can lose a liter or two and still survive. Our performance may be hindered slightly, and we'll talk about that a little bit more in the next videos. But we do have means to dissipate body temperature using evaporation. And during exercise, again, it is an incredibly critical part to that. So I want you to grasp these four concepts: radiation, conduction, convection, evaporation, how important they are. Knowing an example of each of these is really important. And then obviously understanding that when it comes to exercise, evaporation is by far the most important. Okay, we'll see you in the next